find a sequence of elementary matrices E sub 1 through E sub k, such that E sub k times all the way through to E sub 1 times matrix A is equal to the identity matrix. Use this sequence to write both matrix A and the inverse of matrix A as a product of elementary matrices. And here we are given the 2 by 2 matrix A, 0, -3, 1, 2. So, the first thing that we need to do, in order to write both matrix A and the inverse as a product of these elementary matrices, we need to identify the elementary row operations by reducing matrix A to the identity matrix. So here we go. We have our 2 by 2 matrix A, which again is defined as 0, -3, 1, 2. Now, the first thing that I'm going to do is interchange the first and second rows. So we are taking the first row and interchanging it with the second, which leaves us with the 2 by 2 matrix, 1, 2, 0, -3. Now, looking at our second pivot, we realize that we need to scale the second row by a factor of -1/3, which leaves us with the matrix 1, 2, 0, 1. And last but not least, again, looking at our second pivot, to eliminate the entry above it, we're going to do -2 times the second row plus the first row, which leaves us with the matrix 1, 0, 0, 1. Or in other words, the 2 by 2 identity matrix. Woohoo! So looking at these row operations, we can now identify their corresponding elementary matrices. So observe that the first operation interchanges the first and second rows, producing the elementary matrix 0, 1, 1, 0. The second operation scales the second row by a factor of -1/3, producing the corresponding elementary matrix 1, 0, 0, -1/3. And our third operation adds -2 times the second row to the first row, which produces the corresponding elementary matrix 1, -2, 0, 1. So we can now see that the sequence of elementary matrices is E sub 3 times E sub 2 times E sub 1 multiplied by matrix A is equal to the 2 by 2 identity matrix. And from here, we can use the properties of invertible matrices to rewrite matrix A as a product of elementary matrices. So left-hand multiplying this equation by the inverse of the product E sub 3, E sub 2, E sub 1, and simplifying, we can see that matrix A is in fact equal to the inverse of E sub 1 times the inverse of E sub 2 times the inverse of E sub 3. Now, keeping the original elementary matrices in mind, we can see that the inverse of E sub 1 interchanges the second row and the first row, which corresponds to the 2 by 2 elementary matrix 0, 1, 1, 0. We can also see that the inverse of the second elementary matrix will scale the second row by a factor of -3, which corresponds to the 2 by 2 elementary matrix 1, 0, 0, -3. And the inverse of the elementary matrix E sub 3 adds 2 times the second row to the first row, corresponding to the 2 by 2 elementary matrix 1, 2, 0, 1. So therefore, we can now go ahead and write matrix A as the product of these three elementary matrices. 0, 1, 1, 0 times the matrix 1, 0, 0, -3 times the matrix 1, 2, 0, 1. Now, taking the inverse of both sides of the equation, A is equal to the inverse of E sub 1 times the inverse of E sub 2 times the inverse of E sub 3, and applying the properties of invertible matrices to simplify, we see that the inverse of matrix A is in fact equal to the product of the elementary matrices, E sub 3 times E sub 2 times E sub 1. So we can officially state that the inverse of A is equal to the product of the three 2x2 matrices, 1, negative 2, 0, 1, 1, 0, 0, minus 1/3, times 0, 1, 1, 0. Making this our beautiful final answer.